All right, if you would turn to page 13 in your notes where it says Evaluating Limits, and we are looking at number 1, 2, and then I'm going to work my way down that right-hand column. Okay, so now up until this point, you've basically been looking at a picture and evaluating limits. So now we're not going to have a picture. Now you could draw a picture for some of these, but as you work your way down the page, like if you look at something like number 6 there, that might be a little tricky to draw. Or, well, forget it, number 8, that's even trickier to draw, and you're not going to have a calculator. So we have to learn a way to evaluate limits without drawing a picture. Okay, all right, so let's look at number 1 here, and I just threw it up here because it's different than all the rest. This is super easy. Whenever you have a limit, it doesn't matter what number it approaches. If your limit is a constant, like a 7 or a -2 or a 3 or a 1, or in this case, a 5, any limit of a constant will always be that constant. Period, end of story. It's that easy. So memorize that fact, okay? Please memorize that fact. Make sure that you're taking notes here. All right, so now let's look at something that isn't like that. So number 2. So it's really pretty straightforward in the beginning. So what you're basically going to do is whatever number that limit is approaching, in this case a -5/2, you're simply going to take that -5/2 and you're going to plug it in to that x value, and we're going to evaluate. All right, so I'm just going to write it under here. So I'm going to put in a -5/2, but that's a negative x, so that's really just going to become +5/2, right? Plus, and it is 2, but I'm going to make it 4/2, so it makes it a little bit easier for me to add. So then my final answer is 9/2. So if you were to graph this expression right here, okay, it's a negative sloping line, y-intercept at 2. If you look at the limit as x approaches -5/2, it will approach a y value of 9/2. That's all that basically means. Okay, so we're going to do the same thing with number 4. So we're going to plug in -1 here, and I'm going to plug in -1 there as well. Okay, so if you want to pause me, you can do that and see what you end up getting. All right, so I'm going to plug in a 1, so that's going to be negative, and then I'm going to have 1/2 plus, and I plug in a 1, I'm going to get 2, but I'm going to make that 4/2. Oops, 4/2. And then I have +4, because I can't plug anything in there, right? So that's going to be 8/2. And all I'm going to do is add that all up, and that's 11/2, and that's your answer. Okay, number 6. Same thing again. So again, if you want to pause me and try it out, go for it. All right, so then we're going to have this. Now 2 times 3/2 is just 3 plus 4. So it's the negative square root of 7. You don't need to go any further because 7 doesn't break down. Okay, let's do the same thing with number 8. Now number 8 I think is going to require me to have a little bit more space. So I'm just going to go like that. Okay, again, if you want to, go right ahead, pause me, work the question out, and then come on back and you can check your answer. Please make sure that you are writing all this down in your notes packet. All right, so if I plug in -3/2, actually +3/2, I will get -3/2. And then I am going to turn that -3 into -6/2. And that's all going to be over. Now I'm going to square 3/2, which is going to be 9/4. And then I'm going to put 3/2 in, so it'll be +3/2, but I'm going to put that in fourths. So that's going to be +6/4. And then +1, so that's going to be +4/4. All right, so then I have got -9/2 over, and then that is going to be 19/4. Okay, now just remember that when you have a fraction over a fraction that you can keep change flip. So this is coming up, and it's going to get multiplied by 4/19. And then we're just going to work that out. And that is going to be, what do I have? I have negative 18 over 19. There you go. All right, so let's turn the page. And let's go down that second column. All right, so these are trig functions, but we're still going to do the same thing. So we're going to throw in 3 pi over 4. So I've got 2 times the cosine of 3 pi over 4. Well, we know 3 pi over 4 is 45 degrees, but it's in the second quadrant because remember cosine goes pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 in the first, second, third, and fourth quadrant respectively. Okay, so basically I'm just looking for the cosine of 45 degrees, which I know is radical 2 over 2. But again, we're in the second quadrant, and cosine is negative in the second quadrant. Okay, and then I just work that out, and that's going to be negative square root of 2. All right. Now, let's look at number 12. So like I said, normally when we plug in the numbers, everything's fine. But let's look at what happens here when we plug in 5. Okay, so I have a negative, right? So let me keep that in front. But when I plug in 5 into the top, I get 25 minus 25, which is 0, isn't it? And then when I plug 5 into the bottom, I also get 0. Remember, that's called an indeterminate. We cannot have an answer of indeterminate. So this is kind of like the exception to the rule or the special case. Not that it's hard, but what you're going to do is, and I think you could maybe take a guess, that you're going to factor. Because if we factor, look at what happens. Do you see that we have a whole? Really, if you want to think about it that way, right? See our whole? And remember when we had wholes, we would cancel out that factor, right? So what you're going to do is, if you end up with, let me back up, if you plug this number in to the expression and you get an indeterminate, you got to go to plan B. So the plan is, if you get an indeterminate, take your fraction, factor it, cancel your like terms, and now what you're left with, which in this case is negative x, now you're going to plug that 5 in and see what you get. Okay, so we've got the negative sign, right? And now we have just x, so we plug in that 5, and there's your answer. Okay, so not hard, just different. Okay, so let's see what happens on 14. Now, by the way, always try to plug it into the original, because even if it's a fraction and it's factorable, it doesn't necessarily mean that you have to factor. You only have to factor when you get an indeterminate. So when it comes to this one, I know that this trinomial factors, but you should always plug it into the original first, okay? All right, so let's try that. So we're going to plug in 1, so I'm going to have 1 plus 3 minus 10. And then in the bottom, 1 plus 5. See what I'm talking about? There's no indeterminate there, okay? And sometimes what will happen, and I've seen it happen, it happened to me a few times, if you don't do this, you'll get a different answer if you were to factor like we did here and cancel. So this is always the correct answer, plugging in first. The only time that's not going to work is if we get an indeterminate, and that's when you go to your plan B, okay? All right, so let's go back to this. So in the numerator, I am going to get negative 6, and in the denominator, I'm going to get positive 6. So my answer is negative 1. Okay, and that's just basically the starters, all you really need to know for today in terms of evaluating limits if you don't have a picture. Make sure you've taken notes on all of this.